Agathoklis Giaralis is Associate Professor in Civil and Environmental Engineering at Khalifa University Abu Dhabi and an expert on structural dynamics at City University of London. Professor, good to see you. Perhaps it's still too early to give a definitive answer, but what are your initial impressions on the impact of this earthquake and Taiwan's preparedness and resilience?
First of all, thank you very much for having me in the program. I have to say that on average, Taiwan proves to be very resilient given the magnitude and the severity of this particular seismic event. Yes, there are some damages and some buildings have tilted. Yes, there are landslides, but overall, the extent of damages is well within what we would expect from a very well-prepared country for such natural disasters.
And presumably part of the story is engineers, architects building in resilience to infrastructure in anticipation of earthquakes.
That is right. The fact of the matter is that in all seismic, high seismicity regions in the world, there are currently very good seismic codes for earthquake-resistant design of structures. So the knowledge is there, but what makes the difference is how people adhere, the different countries, the different regions adhere to this building codes, how engineers design, and equally important, how they make sure during construction that design plans and are followed religiously, I have to say, and so quality control makes a big difference, as well as preparedness and training of people before, during, and after such an event, what to do and what not to do before, during, and after the event.
I'm guessing this is a story, as far as the engineering goes, around poverty, wealth and corruption. I mean, is that something that poorer countries would be able to achieve, or is earthquake resilience a luxury only affordable, perhaps, by wealthy countries?
Current and modern codes for seismic resistance do take a lot into account on the cost-effective factor. So, in other words, we make sure that we don't put arduous requirement for extra cost to make sure that a structure will sufficiently resist earthquakes, at least for life safety, to meet life safety requirements. So this is out of the question. It is affordable, at least for new build structure. What is there is a challenge there, is what happens with code deficient existing structures that were built different eras before current seismic codes. So, for example, in Taiwan, there was a major revision of the country's standards in 1997. So structures built before that date will be code deficient. And bringing them to the today's requirement level of earthquake resistance would cost a lot of money. Of course, as you mentioned, corruption and I wouldn't say necessarily corruption, but poor mentality or poor quality control during construction and poor awareness of the consequences of what may happen in the event of a major seismic event. If you have some poor quality control in a building that is built in London, okay, you may have some water leaks, for example, or some noise from next doors, which, okay, is disruptive on a daily basis. But if poor construction happens in a high seismic area and a major one happens, a major earthquake event happens, then this is life-threatening. Okay, so the consequences are different.
Professor, we have to leave it there. Great to get your expertise on this. Thank you very much indeed, Professor Agathoklis Giaralis.
Thank you very much.